So now let's talk about the most common activation functions and how to calculate them in TensorFlow and Keras. But now let's start with the regression problem. And in the regression problem, you can see that we have some input. You can see x1, x2, all the way up to xn. And based on these inputs, based on these features, or let's say variables, we want to predict an output which is a numerical variable. Suppose that, for example, based on some features, you want to predict the price of a product. So the price of a product is a numerical variable, so it's a regression problem. So now let's talk about some activation functions which are useful for the output neuron in the regression problem. So the first activation function, which is very famous, is the identity activation function. And basically, the identity activation function takes the input z and it returns the exact value as the output. And now let's talk about another activation function, another important and very famous activation function, which is called ReLU, means rectified linear unit. So as a matter of fact, this is a linear function, but as you can see, it has been rectified for the negative values. So you can see if the value is negative, then it's going to return 0. But if the value is positive, then it's going to return the value itself. So as a matter of fact, this is the formula for calculating the ReLU activation function. And also we can write this in this manner as well. So it is equivalent to the maximum of 0 and the input. So this is the ReLU activation function, or rectified linear unit activation function. And as you can see, the ReLU activation function cannot be negative. I mean, the output of the ReLU activation function cannot be negative. So it's very good for these cases which the output cannot be negative. For example, the price is an example which the output cannot be negative. So in these cases, the ReLU activation function is very good. But for example, there are some cases which the output can be negative. So in those cases, we can use the identity activation function. So now let's talk about how to calculate the ReLU activation function using the TensorFlow in Python programming language. So in order to do so, first of all, suppose that I want to calculate the activation function, the ReLU activation function value for 5. So you can see that this is our input. And in order to calculate the value of the ReLU activation function, I can simply type TF, which is TensorFlow, and then NN, which is the neural network, and N means neural network. And I want to use the ReLU activation function, and I should pass our input, I mean Z. And for example, suppose that I want to store the results in a variable, let's say called H. And now if I print the H variable, and if I run a code, you can see TensorFlow returns 5 because the value is positive. But for example, if you pass -5 and if you run a code, you can see TensorFlow returns 0 because the value is negative. And now let's talk about the binary classification and the useful activation functions for the output neuron. So what do I mean by binary classification? For example, suppose that based on some features, for example, x1 all the way up to xn, we want to predict whether a person has cancer or doesn't have cancer. So you can see the output has two possible values. The person has cancer or doesn't have cancer. So in this case, we have a binary classification. We want to classify the data into two classes. So this is called binary classification. And in these cases, we can use one of the most well-known activation functions, which is called sigmoid. So you can see the output of the sigmoid activation function is between 0 and 1. And you can think of 0 as one class and 1 as the other class. So for example, suppose that 0 is the class that the person doesn't have cancer, and 1 is the class that that person has cancer. So as a matter of fact, this sigmoid returns the probability of having cancer for a person. So for example, if it returns 0.5, it means that the probability of having cancer is 0.5, but for example, if it returns 0.90, it means that the probability of having a cancer is 0.9 for that person. And for example, if a sigmoid activation function returns 0.1 for a data, it means that the probability of having cancer for that person is 0.1. And now in order to classify the data into two classes, we can define a threshold. For example, if you choose 0.5 as the threshold, then we can say that if the probability is greater than 0.5, then we can classify that data as class 1, but if the probability is below 0.5, then we can classify that data as class 0. So now let's talk about how to calculate the sigmoid activation function in TensorFlow. So here we can simply type TensorFlow.neuralnetwork.sigmoid, and for example, suppose that we pass z, which is -5. So now if I run a code, you can see it raises an error because the type of this shouldn't be integer. So for example, I pass -5.0. So now if I run the code again, you can see TensorFlow returns this output, which is the probability, which is very low. But now let's pass, for example, 5. Now you can see the probability is very high, so we can classify that as class 1. And also let's pass 0. So if I run the code, you can see TensorFlow returns 0.5, which is correct according to the chart. So now let's talk about the multi-class classification problem. So you can see that here is the iris flower, and the iris flower has different species. So it has, for example, 3 species. You can see one of them is versicolor, the other one is setosa, and the other one is virginica. And suppose that based on the sepal length and the sepal width, and also the petal length and the petal width, we want to predict whether the flower is versicolor, setosa, or virginica. So this is, as a matter of fact, a multi-class classification. I mean, we want to classify the data into different classes, into multi-classes, not exactly 2 classes, but you want to classify the data to more than 2 classes, for example, 3 classes. So this is called multi-class classification problem. And here is the picture of a multi-class classification problem. You can see that based on different features, you want to predict the output, which is a multi-class classification problem. For example, for the iris dataset, the output is one of those classes, one of those 3 classes, setosa, versicolor, or virginica. So because the iris dataset has 3 classes, so we should have 3 neurons for our output layer. And for example, if another problem has 4 classes as the output, so we should have 4 neurons as the output. But generally, this is the multi-class classification. So here's the general structure of the multi-class classification problem. And for a multi-class classification problem, we can use an activation function, which is called the Softmax activation function. So you can see that for the iris example, we have 3 neurons because we have 3 classes. So you can see this is the first neuron, the second neuron, and the third neuron. So these are the values in the first parts of the neuron 2, 1, and 0.1. And now we want to apply the Softmax activation function and get these values. And as you can see, these values are probabilities. This is the probability of belonging to class 1. This is the probability of belonging to class 2, and this is the probability of belonging to class 3. And for example, based on these probabilities, you can see that this probability is higher, so we can classify the data into first class because this probability is higher. So now let's see how the Softmax activation function converts all of these values into these probabilities. So in order to do so, first of all, we should calculate e to the power of each of these values. So e to the power of 2, e to the power of 1, and e to the power of 0.1. And then because the probabilities are between 0 and 1, so we should normalize all of these values. When I say normalize, I mean we should divide each of these numbers by the summation of these numbers. So we divide this by the summation of these numbers. And also we do the same thing for the others. And if you calculate all of these stuff, you can see that the result of this is 0.66, the result of this is 0.24, and the result of this is 0.10. So now let's summarize the formulation. So in order to convert these numbers into these probabilities, we should use this function. You can see this activation function takes a vector. You can see that this is a vector 2, 1, and 0.1, and each of the elements in this vector is called z sub I. So for example, this is z sub 1 because this is the first data in this vector, z sub 2 and z sub 3. So we are applying this function, e to the power of z sub I divided by the summation of e to the power of these values. And if we calculate this, we are going to get these probabilities. But now let's talk about how to calculate the softmax activation function using TensorFlow and Python. Suppose that our vector z is 2, 1, and 0.1. And suppose that we want to calculate the softmax activation function. So here we simply type softmax tf.neural network.softmax, and we pass z. And if I run a code, you can see TensorFlow returns these values, which you can see the first value is 0.66, the second value is 0.24, and the third value is approximately 0.10. So as you can see, so far we have talked about the activation function of the output layer. But here is a question: what about the activation function of the hidden layers? And usually the activation function which is used for the hidden layers is the ReLU activation function. And for example, if you look at different references, different tutorials, and etc., you can see that usually the default choice for the activation function of the hidden layers is the ReLU activation function. And now in order to summarize what we have discussed, you can see for the output layer, if the problem is a regression problem, we can use the identity activation function or the ReLU activation function based on the problem. And if we have a binary classification problem, we can use the sigmoid activation function. And if we have a multi-class classification problem, we should use the softmax activation function. And for the hidden layers, we usually use the ReLU activation function. And here is another question: do we have other activation functions as well? And the answer is, of course, we have a lot of other activation functions, which I will do my best to cover those activation functions as well in the future parts of this series. Now I really suggest you to watch this video, which is on the screen now.